In the last video we looked at the Pythagorean theorem. In this video we're going to look at mainly its converse. If the Pythagorean theorem says that if you have a right triangle, then the ratio is going to be hypotenuse squared equals leg squared plus leg squared, then simply stated the converse is going to be this, that if this ratio exists, then what type of triangle do you have? You have a right triangle. And this is pretty important that we write in this order, just hypotenuse squared and the leg squared on this side. We'll be comparing this, and what we're going to do is we're going to see what happens if this ratio is less than the leg squared plus leg squared, or what happens if this is actually greater than these two pieces. We'll see what different types of triangles can be developed. So let's take a look at that right now. When we have this, if we look at this, if we know that with the Pythagorean theorem that if this ratio is equal, then what happens is that angle C right here turns out to be a 90-degree angle, which means the side across from it is long enough to make this a right triangle. But what happens if this hypotenuse squared is going to be kind of a little bit shorter? It's going to affect this angle C, making it a little bit less than 90 degrees, giving us an acute angle. So again, if this is less than, then our triangle becomes a little bit smaller. The way I think of that is it becomes an acute triangle. So equal is right, a little bit less than, it gives me a slightly, if this is smaller, it gives me a smaller triangle, which is acute. If this is bigger, then it gives me a bigger triangle or bigger angle C, which results in an obtuse triangle. So I always write it this way: equal is right, less than is acute, greater than is obtuse. And it kind of makes sense in some sort of way that the acute triangle is less than the right triangle, and the obtuse triangle is sort of greater than the right triangle. It's kind of an interesting thing to think about. Well, here's a multiple choice question. It says what type of triangle has side lengths of 14, 11, and 25? I'm going to tell you the answer is none. The reason is we have to think back to the triangle inequality. Okay, the triangle inequality, basically what it said is that if you have you can't just form a triangle out of any three sides. What happens is that the two shorter sides, when you add them together, they have to be greater than the last side. And is that true for us? That's not true. So this doesn't actually even form a triangle. If I drew a 25-inch piece right here, and then I laid 14 on top of it, and then 11 on top of it this way, they wouldn't quite be able to match up. Even if we swung them all the way down, they would just barely touch. Okay, so what happens is we need to check first, does this ratio, does this inequality, does it meet the triangle inequality first? If it does, then we can start using these guys here to say, if it's less than, it's this, if it's equal, it's this, if it's greater than, then it's obtuse. So let's take a look at these. First off, the first step here, it says decide whether the numbers can represent the side lengths of a triangle using the triangle inequality. If it can, then number 2, we want you to classify the triangle as either acute, right, or obtuse. So what we'll do, we take the two smaller numbers, we add them together, 26 plus 35, and we say, is that greater than 62? Turns out this only makes 61, so that's not greater than 62, so what happens is this is not a triangle. We check the other two really quickly. This would be 32, which is greater than 29. This would give us 102, which is definitely greater than this. So these two do make up triangles. So let's see what type of triangles they are. If we take the biggest side, that'd be 29 squared, and we compare it to 14 squared plus 18 squared. When we compare those, gives us 841. When we add these two together, we get 520. Since this is so much greater than 520, the triangle that's greater than is going to be an obtuse triangle. Okay, so this is an obtuse triangle. Over here we'd compare the biggest number, that's 78 squared. We're going to compare that to 30 squared plus 72 squared. When we get these, this is 6,084. This is also 6,084. These are equal. Well, a triangle gives you equal pieces. That's going to be a right triangle. The last thing we're really going to take a look at here, we'll probably look at a story problem as well, but it says the sides and the classification of a triangle are given below. The length of the longest side is the integer. That's kind of important. So when we give it the longest side as the integer, what values of x make the triangle? So when we have this, we know 24 is our hypotenuse, so we'll say 24 squared. We'll use the same ratio. Has to be equal to, because it says right, that'd be x squared plus x minus 5 squared. Okay, let's see what happens when we play with this. This is 576. We'll just simplify this a little bit. This is x squared. This would be when we expand this, or we think of this as x minus 5 times x minus 5, so it would give us x squared minus 10x plus 25 when we FOIL this. Remember, we have to FOIL that. When we combine like terms, we have 576 equals 2x squared minus 10x plus 25. When we move everything over in order to try to solve this, we'll say 2x squared minus 10x. That would equal, let's see, minus 551. At that point, I'm not going to try to factor this. I'm just going to go ahead and use the quadratic formula saying that a equals 2, b equals negative 10, and c equals negative 551. I've done this ahead of time, and when I fully simplify this, I get x equal to, this is kind of a mess, 5 plus or minus 2 times the square root of 1127 all over 2. Okay, so those aren't really nice numbers, but there are two numbers here. One is positive, one's negative. I mean, when you think about this, could x actually be a negative number? Probably not. So when we do this, we're only going to be able to really use the plus part of it here. Okay, we'll take a look just at the second one. We'll leave this one for later on. That's going to be kind of a tougher one. We'll try the same method here. Since it's an acute triangle, we'll just say 15 squared. That has to be less than x squared plus x squared. That'd be 225 is less than 2x squared. We'll divide both sides by 2. We'd have 112.5 is less than x squared. We'll take the square root of both sides, and we'll have positive and negative 10.6 is less than x. Again, since x is going to be one of our side lengths, we can only use the positive version of this. And since we're looking for a range of values, we can't just say any number over 10.6. Part of that is because we know that 15 has to be the longest side. That's what it tells us up in the directions. So we know that this also has to be met with, has to be less than 15. These problems can get a little bit more complicated when we start looking at extra pieces like this one over here. There were a lot of things that were going on that one, so keep that in mind. Let's look at one story problem really fast. This bridge problem, we'll save the storage shed for a little while later. It says many railroad bridges are designed using the triangular structures like the one on the diagram. All 5 triangles are congruent. So all 5 of these, 1, 2, 3, 4, 5, are all congruent. The length of the bridge is 48, the height is 15. When we look at this, that means this piece, and this piece are congruent to these two pieces up here. 48 divided by 3 is 16, so each one of these pieces are 16 feet. We'll go through and we'll think about these other pieces. They kind of look like some sort of isosceles triangle since these pieces have to be congruent. We're probably going to say this is going to be an isosceles triangle of some kind. So we can drop down our altitude something like this. 16 divided by 2 would make this 8 feet and 8 feet. We know that this height here is 15. And we learned about Pythagorean triples a while ago. So if this is 8 over here, we have 15 here. We could use the Pythagorean theorem or the idea of Pythagorean triples to find that that is a hypotenuse of 17. So each of these lengths is 17. It says how many feet of material are needed to build one side of the bridge as shown. Well, we just look at how many pieces of 16 we have, how many pieces of 17 we have, and we should be able to find our answer. So let's see. How many pieces of 16 do we have? We have 1, 2, 3, 4, 5. So we'll say 5 times 16, which is 80. And there's 1, 2, 3, 4, 5, 6 pieces of 17. Let's see. 6 would be 60 plus 42, so that would be 102. So we probably need about 182 feet of material in order to build this side of the bridge. Again, there's also these little rails and everything if that's a railroad, but this is all it's really asking us for, so we're really just looking for 182 feet. These are some of the applications of the converse of the Pythagorean theorem. I think this is a really important concept in order to figure out how to classify a triangle. If it's less than, remember that it's going to be an acute triangle. If it's greater than, it's going to be an obtuse triangle. It always matters, make sure that you have the hypotenuse on the far left side. If you switch it to the right side, it's going to actually switch these relationships around and be hard to memorize. Pythagorean theorem and its converse.